here comes the third Arduino based experiment, sensor and motor interfacing. We will be demonstrating 3 tasks here. So first task, ultrasonic sensor. We will measure distance from an object using ultrasonic sensor. So first of all, how does ultrasonic sensor perform? In ultrasonic sensor, there are 2 types of connection. One is the trigger and another is the echo. So let's say this is the trigger portion and this is the echo. So trigger will trigger some signals, ultrasonic sound, and whenever there is an object, let's say here, and this object will reflect back that sound. So it will reflect back and then echo will receive that signal. So the duration of that traversing of this signal from this trigger to echo will be measured using Arduino. Then we will calculate the distance because we know the distance of sound in air medium. So that's the main portion. So we have trigger pin to trigger that signal and we have a echo pin to receive that signal, and this 5-volt portion, that is basically for powering up that sensor, and this ground to connect the ground with this. And in physical domain we generally place an object and then measure the distance, but here we are simulating this in Proteus, and to simulate this we are using a resistance here, a potentiometer to be more specific. So a potentiometer will be used to simulate this sonar sensor, and the model of this sonar sensor is basically HCSR04, and this is the most common one. This is readily available in markets, so you also can buy it. Now this circuit. So first of all, I already mentioned that trigger and echo. Trigger is the output pin and echo is the input pin, and they are connected to digital pin 9 and 10. You can connect to other pins as well. Then 5-volt is connected to a power signal of 5-volt, and then the ground is connected to ground. And in this first task we will be showing our distance that will be calculated in microcontroller, that is Arduino. We will be showing the distance in virtual terminal. That's why this virtual terminal is connected here, and you already know that the virtual terminal connection, like the TX of Arduino will be connected to RX of virtual terminal, and similarly the RX of Arduino will be connected to TX of virtual terminal. So this is the virtual terminal connection. So I just described the whole circuit configuration. Let's move on to code. So first of all, I already told you that I have used trigger pin as 9 and echo pin as 10. So this is just a variable definition. That means I just define the pin numbers, and since the pins are constant, that's why they are defined at constant integer. And if you want to define that using define parameter, just like previous experiment, you can also do that. That will be no problem. So either you can use define or constant int, or also that only int will be okay also. So anyway, so first of all I just define the pin numbers, pin 9 and 10. Then I define some variables. First of all, a long duration where I will store the millisecond or microsecond. Let me check. So it will be microsecond. So I will store that microsecond in duration variable, and in microsecond this time might be higher. That's why I have defined is as a long variable. There are different types like long, short. So this will be long integer. That's why long, then duration. And then the distance, we will be calculating the distance in centimeter. So just integer, then distance. And to be more specific, I think this distance should be described in float or double. So this will be better if you describe it float distance or double distance, because distance could be 2.7 centimeter or 2.5 centimeter. But if you can define it integer, then it won't give you the this fractional portion. It will give just the integer portion. So now in this void setup portion, first of all I just defined that trigger pin as output pin, since it will send some signal at the output direction, and then the echo pin as input pin, since it will receive the signal, that's why this is input. And then the serial begin 9600, that means you are starting the serial communication with baud rate 9600 bit per second. Now within the void loop, first of all you just send a low signal to trigger pin, that means you just clear the trigger pin, and then you have a delay of 2 microseconds. So you just make your environment ready. Now you just send a high signal to trigger pin. So now you just send the high ultrasonic sound signal, and for 10 microseconds. So you send this signal for about 10 microseconds, that's why the second line delay microsecond 10, and then you just turn off that high signal, that's why digital write trigger pin low. So up to this you just send the trigger signal. All you need to receive that signal whenever it will be reflected back. That's why next you have received this using pulse in function. So what does pulse in do? Pulse in basically measure the duration of high pulse. So it will receive high pulse at echo pin, that's why first the pin number, that is echo pin, you are receiving at echo pin. So echo pin, and the signal you will be considering is high signal. So whenever that high signal will be received, it will calculate that duration, and you have stored that duration in duration variable. So let me clear this all first. So now if you notice closely, so you have already got the duration. Now you need to calculate the distance from it, and you already know that the formula that time equal to distance divided by velocity, right? So the velocity of sound is 343 meter per second. So now if you convert this to centimeter per microsecond, then it will be 0.0343 centimeter per microseconds. That's why that 0.0343 portion came here. So you are calculating this distance. So distance equal to time multiplied by velocity. So this will be the time and this will be velocity. Now why this divided by 2? Because the signal consists of the sending portion, sending time, and also the receiving time. So you need to divide it by 2 to have a on type of duration, because you don't need to calculate the total duration of sending and receiving, you just need to calculate on portion. And that's why you have just divided it by 2. So far you have calculated the distance, and now if you want to print that, so serial print and distance, and then serial print ln distance. So it will print your distance like this, distance, and then there will be a colon as given here, distance colon, and also there is a space, so there will be a blank space, then the distance, let's say 2 centimeter, will be printed in virtual terminal. So this is the code I just demonstrated. So first task is completed. You need to construct the circuit, and there is a potentiometer to simulate the distance. Here I mentioned here. So this potentiometer, so you will vary that potentiometer whenever you perform the simulation, and you will observe the effects in virtual terminal. So that is our first task. So let's move to second task, which is servo motor. So we need to control a servo motor using Arduino. So first of all, what is a servo motor? It's kind of motor, but in let's say DC motor, that will rotate continuously, but servo motor is more of angular control. So this servo motor actually can change from 0 degree to 180 degree. So you can change its there is a shaft in servo motor, so you can let's say if this is a motor and this is a shaft, so you can rotate this, and you can have a precise rotation. That means you can have, let's say, 90 degree rotation. So if that is the reference, then 90 degree rotation will be like this. So if you rotate this just like this up to this precise rotation point, then you can use servo motor. So in servo motor there are 3 connections. So one is the voltage supply. I have just supplied 5 volt, and another one is the ground signal, and the middle one, which is basically the connection where you give the high signal to rotate it. So that's why this pin number 9 we have used that our servo in pin number 9. And this is the simplest connection in this portion, and in this portion if you notice we have just connected a potentiometer to vary the servo position. So this potentiometer is well known to you, I believe. This connection already shown in task 1. So just positive supply here and the negative supply here, and you can sense this position as well. So I will be demonstrating this when I will demonstrate the simulation in Proteus. So you need to construct the circuit, and the code will be using the example code from Arduino, and I will be demonstrating these codes as well, so don't worry.